Hi, welcome to a complete course in calculus. This is Tedessa. So in this review, I'll show you how to find the derivative of an integral. So basically, we'll do this using two different methods, either using the second fundamental theorem of calculus or directly by finding the antiderivative. So let me show you the first method, method one, which is using the second fundamental theorem of calculus. So the second fundamental theorem of calculus says, if you have a function, let's say f of x, from a to any function g of x, it can be g of x, can be x, anything. So f of t dt, then the derivative of this function becomes f evaluated at g of x times the derivative of g. Okay, that's what the second fundamental theorem of calculus says. But remember, keep in mind that this function f should be, capital F should be defined between, on an interval I containing this point A and, the value of g at x, g of x also should be in this interval. That's very important. And the lower limit must be a number, the upper is a variable. That's what it says. Now, in our case, we do have x to x plus 2. So it is from x to x plus 2. So basically what I'm going to do is, let's say, this is the interval containing these 2 points. So what I'm going to do is I'll just pick any point A. Between x and x plus 2, there is another number, say A, okay? So if you want to be, just precise, do we really have that A? The answer is yes. If x is 1, x plus 2 is 3, right? Between 1 and 3, there is 1.5, right? Any number. That's what I mean. Between x and x plus 2, there is a number. So I pick that number, random number between x and x plus 2. So what that means that f of x can be written as what? From x to a for t plus 1 dt plus a to x plus 2 for t plus 1 dt. I'm using the additive property. That is very important, okay? And now, if you remember this property of integral, a to b of f of t dt is the same as what? Minus of b to a f of 2 dt. So basically you can change the limit of integration, the lower limit and the upper limit, and then you need to have a minus sign in front. That's what it says. So in this case here, it becomes a to x. So why we are doing all that? We just want to make sure that it's exactly like the second fundamental theorem of calculus. That's it. Now I can find the derivative. The derivative of the sum is the sum of the derivatives. So it will be minus of, what is the derivative of this integral? Keep the minus. It becomes what? 4 evaluated at this x, which is x plus 1, right? Times the derivative of x, which is 1. That's it. I'm done with the first piece. Plus, right? And the second one will be 4 evaluated at this guy. That's what my g of x is. So which is x plus 2 plus 1 times the derivative of x plus 2, which is 1. In this case also times the derivative of x, which is 1. That's it. So this is what? Negative 4x minus 1 plus 4x plus 8 plus 1. So now the remains 4x cancels out. So the minus 1 cancels out. So the answer is what? 8. That is one method if you are directly applying the second fundamental theorem of calculus. So the second method is without using the second fundamental theorem of calculus, you can use the fundamental theorem of calculus to find the antiderivative. So simply just, which means find capital F of x. So it will be x into 2x plus 2 4t plus 1 dt. So this is, what is the antiderivative of 4t? It is 4t squared over 2 plus t from x to x plus 2. So this cancels out. It's 2t squared plus t. That is what the antiderivative is. Now I need to evaluate that. So at x plus 2, it will be x plus 2 squared plus x plus 2, okay? Minus, this is what the first piece is. At x, it will be 2x squared plus 6. Now, If you simplify that, x plus 2 squared means x squared plus 4x plus 4 plus x plus 2. If you distribute that guy, the minus, it will be minus 2x squared minus x. So this is 2x squared plus 8x plus 8 plus x plus 2 minus 2x squared minus 6. I'm just finding capital F, okay, using the fundamental theorem of calculus. So this will be 2x squared minus 2x squared, it cancel out. 8x, you know, this will be cancel out. So the answer will be 8x plus, I believe 8 plus 2 is 10. That's what we're gonna have. So this is what f of x is. But the question is find the derivative, right? So I just find the derivative of this guy, which is 8. So in both cases, the answer should be the same. Thank you very much. I'll see you in the next video.